All right, guys, so here is, let's start with the warm-up. We're going to pause the video. Please pause the video and complete the warm-up, and as soon as you're done, hit play, and we can go through it. So hopefully by now you got a chance to do these problems. Basically, with arithmetic mean, we can actually plug these patterns into the arithmetic formula. So, excuse me. Just make sure. There you go. All right. So for the first one, we know the first term. We know it's plus some common difference because we said it's arithmetic. And we actually have the sixth term is 66. So I plug a 6 in for the term, and I know it should equal 66. And when I solve this equation, I get d equals 12, which means every time you're adding 12. So if you want to fill in the missing information, you would do plus 12 to get 18 plus 12 plus 12 plus 12, and eventually you get to 66. In number 2, I do the same thing. I know the first term is 8. I knew the seventh term, so I plug a 7 in for n, is 53. I don't know the common difference, so if I solve this equation for d, you end up with 7.5. So you can add 7.5 every time to get your new numbers. So today we're going to go ahead and learn about geometric mean. Geometric mean is where you're able to find missing terms in between problems, just like what we did here, but instead of it being an arithmetic sequence, it's going to be a geometric sequence. All right. So right now, I want you to get together with the person next to you, and I want you to think what we did about, we did the other day with the arithmetic mean. And I want you to take 2 minutes with your partner to answer the following 2 questions. And pause the video, and when you're done, it should only take about a minute or 2. We're going to move on to the next slide. So go ahead and pause the video, and when we're done, we'll play it. So hopefully by now you got a chance to do that. We'll have a little task for you. This is on page 82. What I want you to do with your partner is these are geometric sequences. And without learning how to do it, I want you to take about 4 minutes and see if you could figure out a way to find the missing term, to find out what should go here and what should go in terms 2 and 3 right here and here. Don't worry if you can't figure out the answer. The idea is for you to try to come up with a strategy knowing that these are actually geometric. This is a geometric pattern. So you're multiplying the same thing every single time to go from 7 all the way up to 875 on the 4th term. Go ahead and pause the video, and after about 3 to 4 minutes, you can play the video. All right. So hopefully by now you found a way to figure out what the answer is. Now, I want you to know if you've found your own method, that's fine. You don't always have to use the method that I teach you as long as yours works for every single problem. But the one way that always works is being able to figure out and think about, well, that if you're multiplying the same thing, that would mean like you're multiplying times r, times some rate, times r, and times r. Well, in a way, you're taking your first term, you're going to be multiplying by r 3 times, which is the same thing as r to the 3rd power, and you're eventually going to get to 875. So the way that I can write that out, we did this here, but I want to make it a little neater, is like saying you're taking the number 7 and you're going to multiplying it by some rate 3 separate times, and you'll eventually get to 875. Well, the way that you can solve this is, first of all, divide both sides by 7. Get rid of the 7. And when you divide 875 by 7, you get 125. So that means that you're multiplying some rate 3 times by itself to get to 125. Well, the way that you can actually get rid of the 3rd power, the way that we get rid of s squared is we square root it. Well, you can actually take the cubed root of a number, which means you're figuring out, instead of multiplying r 3 times, you're doing the opposite of that, and that'll get rid of it. The way that you do that on your calculator is this. All right, so since you took the cubed root on this side, you also have to take the cubed root on this side. Whatever we do to one side, we have to do to the other side. So you're left with r equals, and now we have to find the cubed root of 125. So on your calculator, if you go to the math button, which is right over here, you can see right on option number 4, you have the cubed root of any number. So if you hit enter and put in a 125, we're going to find out what number times itself 3 times would equal 125. If you hit enter, you get 5. So r equals 5. And if you multiply by 5 and then multiply by 5 again and multiply by 5 again, you will get 875. So you're able to find out the missing terms that way. So let me give you another, and again, you're just multiplying by 5. So here, let's revisit number 1, the one that you try to figure out. Here, the answer was 6. So if you found a good way to do it, that's great. The way that you would have done it our way is you wouldn't have known that this was a 6. You would have said that you're really multiplying by some rate, and then you're multiplying by some rate again. So here, you're taking the number 3, the first term, and you're multiplying by r, but you're multiplying it by r twice, so that's like r squared. And you're going to eventually get to 12. Well, here if you divide both sides by 3, you get r squared equals 4. And now if you take the square root of both sides, which on your key, well, the square root of 4 is 2, but just so you know, square root button is second, and then the square button, you get an answer of 2. So r equals 2. And that means that you multiply times 2 to get to your sequences. Now, you could have also written a geometric formula once you have this information, but that's a little bit different. This is how you're going to find out missing terms in a geometric sequence. So right now in class, you're going to complete page 82 and 83, numbers 3 and 4. And then your homework is page 86, numbers 6 through 9. And you can rewatch this video again if you're having a little bit of concern.